welcome everyone to workshop 3A on aquatic biodiversity and people. Mariana Mehrhoff and Markus Fischer are my co-conveners here. I'm Sonja Jenik from the Leibniz Institute of Freshwater Ecology and Inland Fisheries, and will guide you through the talks and the discussion this morning with support from Mariana and Markus as well. So for now, I would like to introduce our first speaker, that is Dr. Dave Tickner. Dave is Chief Freshwater Advisor at WWF and based in the UK, and he advises on international river conservation, water resources programs, leads research projects, and engages in governments, private sector on water and all sustainability issues. He actually began his career in UK's Environment Ministry before completing a PhD in environmental sciences, and then he joined WWF as a policy advocate over 20 years ago, I thought, and led particularly the influential program for the Danube River, and he is now the chief advisor on freshwater issues at WWF. He's also a research fellow at the University of East Anglia in the UK, and an associate editor in Frontiers in Environmental Science. And he sits on the UK's government's Darwin Expert Committee. So Dave will give a presentation, Think Like a River, what scientists should do differently to save the world's freshwater biodiversity. I'm really looking forward to your presentation, Dave, and the floor is yours.
Thanks very much, Sonja. I hope everyone can hear me, and I hope you can see the slides that are on the screen, or the slide. And it's a pleasure to be here. I appreciate the invitation. Yeah, I'd like to offer some, I guess, reflections born of the kind of experiences Sonja's outlined, the kind of experiences I've had on how scientists, scientific institutions might need to evolve in order to address some of the challenges facing the world's freshwater biodiversity. I thought I'd start with this question, which seems quite timely given what's happening with the global economy at the moment. When the global stock markets collapse, what happens? What kind of response do we see? Of course, we've seen this a number of times in history. The pictures here come from 2008, the global financial crisis then. And it was very interesting to see government responses, and indeed private sector responses to that crash in stock markets and other financial indices. I was reading a piece from the Atlantic Council the other day, and they calculate that since 2008, governments around the world have pumped $250 trillion into the global economy through quantitative easing and similar measures in order to try and reverse and sustain the reversal of the kind of crash that we saw in 2008, $250 trillion. And they've done it in quite a coordinated fashion. I was listening to a podcast the other day with Julia Gillard, who at the time in 2008 was Australia's Deputy Prime Minister. Later, she became Prime Minister. And one of the points she was emphatic about in relation to the 2008 crash was that this was a very coordinated effort across G20 nations. So quite a response to a crashing global economy. Well, let's take a look at another stock index, if you like, which has also crashed by even further and over a much longer duration. The graph here is the Freshwater Living Planet Index. Living Planet Index is published every couple of years by WWF, my organization, and ZSL, Zoological Society of London. And essentially, it's a stock market index. But really what it shows is the changes in stock, or if you like, population abundance of vertebrate species around the world. And when we particularly look at the Freshwater Living Planet Index, we see that since a baseline of 1970, that's declined by 83%. Now, for me, this is quite personal because I was born essentially on the left-hand side of that graph in late 1969. So I've only ever lived I've only ever known a world in which there is less and less biodiversity, in particular freshwater biodiversity. And I should say this 83%, that's about twice the rate, in fact, it's more than twice the rate of decline we see for terrestrial populations and marine populations. My eldest son, Matthew, who you can see in the photo, he was born on the right-hand side of that graph in 2015. And so increasingly I find myself looking at this graph thinking, well, what kind of world will Matthew and his generation grow up to know? Will they also know a world in which there's only ever less and less wildlife, a world that's constantly impoverished of nature? Or will they know a different world, a world where we can actually restore some of this biodiversity, a world where we can bend this curve back upwards? The good news is that we sort of know how to do that. We know how to bend that curve back upwards, not just for freshwater biodiversity, but for other types of biodiversity as well. But focusing on freshwater biodiversity, I led a piece of work for WWF involving a bunch of scientists from around the world and various policy wonks back in 2019 to try to define, okay, well, if we are to bend the freshwater biodiversity curve, what does that look like? What do we need to do? And we defined a framework built on 6 actions. We called it an emergency recovery plan because we thought an 83% decline in the stock market index really is an emergency. And the 6 actions we defined, of course, they look slightly different in different places at different times, but you can see them on the right-hand side there. They're about restoring river flows, improving water quality, protecting the most critical habitats, sorting out unsustainable extractive industries, addressing species, non-native species invasions, and really restoring connectivity in rivers. And really that's sets the frame for what we think the world needs to do in order to bend that curve. Now, of course, actually doing those things is pretty complex, and it requires, I think, quite radical action from a wide range of stakeholders. There's the old adage that the definition of insanity is doing the same thing over and over again, all the while expecting different results. Well, if we want different results, if we want to bend that curve back up, we need to do things differently. And given the 83% decline, we really need to do things radically different. And of course, that cuts across policy sectors, public policy, government decision makers. It cuts across business sectors. Just to give you a flavor of some of the debates that are going on about what that might look like in the conservation sector, there's lots going on at the moment, as everybody knows, around the post-2020 Global Biodiversity Framework, the CBD COP that's coming up next month. A lot of what that framework has looked like has been focused around conservation and restoration of land and sea. That framing is profoundly unhelpful from a freshwater biodiversity perspective. Around a third of vertebrate species are freshwater species. They can't live on land and they don't live in the sea. They live in rivers or lakes or freshwater wetlands. So we need to change that framing to include freshwater or inland waters or whatever the language is. We also need to include specific targets. I've been doing a bit of work with a bunch of organizations across science and NGO communities to try to develop some quantitative targets, global targets for restoration of rivers and other inland waters. That debate is very live at the moment. It involves sort of taking and implementing things like the EU Green Deal, existing legislation, which is quite progressive, like the Water Framework Directive, but which governments have struggled to implement. In the private sector, there's similar initiatives going on to try to sort of redirect private sector efforts such that they become much more sustainable and actually help restore nature rather than destroying it. I won't go into too much more detail about that. We don't have enough time. The question I wanted to pose really is, well, if radical action is needed, if we're going to bend that curve, what does that mean for the science community? Do we carry on doing science in the same way, or do we think about doing it in slightly different ways? So just to unpack that a little bit, and I'm guided here and inspired by 3 quotes. The first you'll see there was from Tony Allen. Tony died a short while ago. He was for those who don't know him, he was a professor in the geography department at King's College in London. He was the man who came up with the concept of virtual water, and he won the Stockholm Water Prize for that concept and for other contributions. Now, I knew Tony quite well, and he was a man who was passionate about changing the world. And one of the things he said, which really stuck with me, is that there are really sort of two types of scientists in the world. There are empirical scientists who are interested in knowledge for its own sake, and there are activist scientists who want to use knowledge to change the world. Talking of change, Greta Thunberg, who needs, I'm sure, no introduction, she said a couple of years ago, and I think she was mainly talking to the governments of this world and perhaps some fossil fuel industry executives. She said, change is coming, whether you like it or not. I think implicit in what she said there is the idea that her generation, the next generation of scientists, of activists, if you like, they're not going to be passive about this. They want to see the world change, and they will march on the streets, advocate, change their buying habits, and do other things in order to bring that change about. But in thinking about, okay, well, if we're going to have change, and if potentially we need to encourage some of the next generation to become activist scientists, what does that actually look like, and what does it mean for scientific institutions? And a while back, I stumbled across this quote from David Brower. We must begin thinking like a river if we're to leave a legacy of beauty and life. David Brower was an eminent US environmentalist. He set up the Sierra Club and Friends of the Earth and other initiatives. And I was struck by this quote, and I thought, well, what did he mean, thinking like a river? So I've done a little bit of thinking about that. And it feels to me that thinking like a river might involve three different dimensions. Rivers, if you like, they're dynamic and very complex entities. And in some ways, I think if we're to train the next generation of scientists to be activist scientists, to really help the radical action that's needed to bend that curve of biodiversity loss back upwards, we need to help that generation of scientists to understand the dynamism and complexity of human biodiversity interactions, including around freshwater biodiversity, to understand potential pathways for bringing about change across those human biodiversity systems, and to really, and this is a critical point, to really understand the potential trade-offs that might be implicit in any of those pathways, and to understand how to navigate those trade-offs working with a wide range of stakeholders. Rivers, I think, are also, they're inevitable. And what I mean by that is rivers just keep going, and they keep going till they reach their end point, usually reaching the sea. They will just flow downhill. They will find a way. But they're also very adaptable. They will change course depending on conditions. They will avulse and so on. And it feels to me that's quite a nice parallel for the kind of activist science that we need as well. We need to train the next generation of scientists to be able to think very strategically about where they want to get to, where they want to help the world to get to. But we also need to help them understand how to deploy different tactics at different times and different places with different stakeholders in order to achieve their strategic objectives. And lastly, rivers are inspiring. For me anyway, and I think for many other people, they're very important in lots of different cultures. And it feels to me that there is something that we need to help the next generation of scientists to do, and that is changing the framing of freshwater biodiversity. It's often either ignored or it has a sort of very negative connotations, but yet some of the rivers tell the best stories in the world, according to some of the children's literature that I've been reading to my son Matthew. So how do we teach the next generation of scientists these kinds of skills as well as the technical knowledge that they need on freshwater biodiversity? So in thinking about all of this, I've been reflecting on some of my engagement with a wide range of academic and scientific institutions here in the UK and elsewhere in Europe. And it feels to me that a lot of those institutions and a lot of the scientists I engage, they're brilliant technical experts, and they're genuinely committed to trying to change the world. But to be candid, I think very few of them are really equipped to do that. They've never been taught the kind of skills that I just mentioned. I know when I went to university, I was never taught those skills. The emphasis was always very much on technical knowledge, which in and of itself is no longer enough. There are some very practical things I think that could be embedded in some of those institutions, embedded in degree programs, building on those kinds of soft skill sets that I just mentioned. And they could be done through a whole bunch of mechanisms, some of which already happen, but perhaps only in a sort of niche way. So the challenge is scaling up things like real skill-based degree modules, for example. Putting in place professors in practice, people who aren't in academics by training, but who can help academics and the next generation of scientists understand how to use knowledge to change the world. Perhaps even setting up dedicated institutions. The University of Cambridge has an Institute for Sustainability Leadership, which does this kind of stuff. I've not heard of similar things in other parts of the world. Perhaps that's my own ignorance. Secondments, partnerships with NGOs or government institutions to help students understand how to bring about change. These kinds of things are possibilities as well. And importantly, of course, all of this needs to be funded. Governments have a key role in this. Institutions like the European Commission have a key role in this. But for scientific institutions, I think there's a whole bunch of untapped funding streams, charitable foundations, philanthropic donors who are dedicated to try and bring about change, who are dedicated to try and build capacity to do that, and which I suspect scientific institutions haven't yet tapped into, but who could help to do this. So as I say, some reflections. I'm going to leave you with these key messages. I'm not going to read them out because they really reiterate what I've just said, and you can read them for yourself. But perhaps one final reflection, and it's linked to COP27 that's happening in Egypt even as we speak. So thinking about the way the climate change debate has evolved over, well, the 25 years that I've been in the environmental movement, I think it's reached a point now where, although there are still some climate deniers out there, most serious decision makers in government and the private sector no longer contest the scientific fact that climate change is happening and is caused by human activity. The debate is much more about what we do about this, the policy response. When I think about biodiversity, and in particular freshwater biodiversity, we're nowhere near that point. Most policymakers don't even know that there's such a crisis in freshwater biodiversity. And if they do, perhaps they're not particularly interested in prioritizing action to address it. One of the reasons I think why the climate change debate has reached the point where it's at is just because so many climate scientists around the world over such a period of time have become more activist in their approach. And that can involve marching on the street, but sometimes it just involves better communication of knowledge, really targeted influencing efforts. I would love to see the freshwater biodiversity community, the biodiversity community more generally, learn that lesson from the climate science community and become more activist. And in doing so, perhaps thinking more like rivers. I'll finish there. Thank you.
Thank you very much. I think my camera takes a little while to switch on for this very engaging talk. And being a river ecologist myself, it definitely spoke very much to my own experience and my own heart. So the way we thought we proceed is that we have the 4 talks in a row and afterwards spend a bit of time with a discussion. And it's my great pleasure to introduce Dr. Astrid Schmidt-Kloiber, who has become a dear friend of mine as well. She's a scientist at the University of Natural Resources and Life Science, also known as BOKU in German-speaking countries, at the Institute of Hydrobiology and Aquatic Ecosystem Management. Astrid is an expert in the field of freshwater ecology, focusing particularly on benthic invertebrate ecology and species traits, so those little small critters that live on and below the surface, hidden by the water and sometimes below the surface. And but she has from this particular ecological focus moved a bit away through the past years to include biodiversity data aspects, mobilization, data management, publishing of data, making data available. And I'm very happy that she agreed to give a talk here on the relevance of freshwater biodiversity data. So Astrid, the next 15 minutes are for you here.
Thanks, Sonja, once again for this kind introduction. It's a pleasure for me to talk here today and to give a little bit or to add a little bit of a data aspect to what Dave already presented now here. So I want to frame my talk around which policy frameworks in Europe exist and how do they serve freshwater biodiversity monitoring or freshwater biodiversity. And then I also want to give some examples of these biodiversity data. So let me start with the very basic questions. Why do we need freshwater biodiversity data? And here I should have thought that I'm talking after Dave, so and I should have known that he will present this graph, but you all know it. And as you can see, all the other realms, in all the other realms, the biodiversity decreased, but for freshwater, this is most imminent. So we all know that the freshwater ecosystems are under threat. And here I'm talking not only about these classical threats like organic pollution or hydromorphical alteration, but also these new emerging threats like microplastic or new substances. So basically, if we want to know why biodiversity is changing and what this means for related processes or ecosystem functioning, we need to know the basics. And the basics in biodiversity is to know where the species are sitting. So really, to put it simple, if we do not know where the species live, we cannot make predictions for the future, and we can also not make good conservation decisions. So again, a graph that you already know, if we want to bend the curve, we need to take action. And for this action, we actually also do need data. Now, let me look at the policy frameworks in Europe. We have these three older frameworks, like the Birds Directive from 1979, the Habitats Directive from 1992, which is related to the Nature 2000 network of protected areas, and the Water Framework Directive from the year 2000. But recently, we got another kind of framework, the biodiversity strategy, which has the aim to put biodiversity on fast track of recovery again, and then to ensure that the ecosystems further deliver the ecosystem services in a long term, which to my mind is a very anthropocentric view, but okay. And the biodiversity strategy includes something very nice, because what should be reached is that degraded ecosystems should be restored, which means 30% of the land and 30% of the sea. And here again, what Dave already mentioned, not specifically mentioning freshwaters, but these areas should become protected areas within the next years. And for rivers, the strategy includes the restoration of 25,000 river kilometers to be free flowing again. And then we have other directives as well that I'm not going to tackle in this talk. So what does this mean for freshwater biodiversity data? Or what do these policy means for data? Do they support biodiversity research or not? So if we look at the Birds Directive, the focus of the Birds Directive is conservation. And the idea is to protect all the 500 wild living birds in Europe. So the data that are collected by the Birds Directive are on species level. And we do have a lot of good data. And this is also because of citizen scientists, because bird watchers are basically everywhere, and they produce a wide variety of good data. And then if you look at the Habitat Directive here, again, the focus is on conservation. So threatened species and habitats should be protected within this directive. And also here, the data that we get is on species level. So in the annexes of the Habitat Directive, there are more than 1,000 species listed. And the last directive I want to mention here is the Water Framework Directive. Here, the focus, as we all know, is on water quality. And the real advantage of this strategy is that we have a real big network of sites, like you can see in the map down here. Okay, what does this now mean for freshwater data? As I said, for the Birds Directive, we have a lot of good data, but what is actually missing is a clear definition which species are freshwater, which species are freshwater dependent, or which species are purely terrestrial. So this is missing here. And regarding the Habitat Directive, only few and selected organisms are on this directive. So for freshwater, this means it's mostly fishes and odonates and crayfish. So it's only selected organisms and only selected species where we get data from. And if you look at the Water Framework Directive, not all organism groups are monitored within the Water Framework Directive. Not all water bodies are monitored, so there is no specific monitoring of wetlands and also no monitoring of rivers that are smaller than 10 square kilometers. Then, to my mind, the reference sites are underrepresented in the network of Water Framework Directive sites. And then we have the issue with imprecise identification level of some groups. So this is not related to fishes, but everything that is smaller. In southern European countries, for example, we don't, invertebrates are only identified to genus or even family level. And the most pressing issue here is that we do not have the raw data. All these directives, for all the directives, you need to report it to the European Union, but for the Water Framework Directive, only the water quality status of a specific site is reported and not the species that are behind this status. So the raw data are all within the member states, and even within the member states, they are scattered. So no raw data available. And there is a project in that is currently going on. Oops, what is happening here? That is currently going on in Europe. It is called Europabon, and here they have also made an overview about these different directives and how they deliver data. And as you can see in the last row, none of these directives delivers open data. So this is really a main issue here. Okay, and if we look at the biodiversity strategy now, there is no monitoring scheme connected to this biodiversity strategy yet. But as I said, there's this Europabon project, and they are currently designing an European biodiversity monitoring framework. And this will be based on so-called essential biodiversity variables. Okay, this brings me to my very first conclusion. European biodiversity monitoring data is still very sparse in time and scale, and it covers only limited taxa. If we now look into national biodiversity monitoring in Europe, I have to say the situation is very complex, and there is actually no comprehensive overview what is happening in which member state. So the information is very scattered also in terms of data. Where do data go? Where are they published and so on? There seems to be a little coordination between the member states with unclear and not harmonized targets. And of course, many of the countries lack resources for doing freshwater specific biodiversity monitoring. And the main issue here also is there are only few countries, and to mine, so I personally only know one in Switzerland, is that there is no specific freshwater monitoring. So again, if you look at the graph that was produced by Europabon, you can see that, the scattered situation and not all or only few EBVs are monitored in the different countries of Europe. Okay, which brings me to my second conclusion. We need we need an integration of the available data, and we need new harmonized monitoring schemes. Okay, but the good news, there are all freshwater biodiversity data out there, and they are available. And as I said, those are mostly birds or fish data. And I wanted to make a difference and decided to show you something about caddisflies here. So I queried two species of caddisflies, Rheocophila dorsalis and Rheocophila nubila, from the Global Freshwater Information Facility, also known as GBIF. And as you can see on the left side, this is a very widespread species, and on the right side, Rheocophila nubila seems to be rather rare in Europe. And now we have to ask the question, why are, for example, no occurrence points here in France? Is this really, does the species not occur here, or is this an artifact of our data availability? And for the caddisfly, we are in the lucky situation that we do have a distribution atlas of European Trichoptera, so caddisflies, where we have more data collected. And you can see in the right picture here, the blue points. These are the points of Rheocophila dorsalis. And here you can actually see that there are points in France or also even here in Spain. What you also can see here is there is a clear boundary, distribution boundary between these species, with Rheocophila dorsalis appearing more in the western parts and Rheocophila nubila in the eastern and northern parts. So if we again look at the GBIF map of Rheocophila nubila, we can see that they are much more distributed over here in the eastern parts and also in the northern parts. So this is much more abundant than we would know from the GBIF data. Okay, and then I thought we do have very good citizen science data for birds and for butterflies, for example. So I thought I might look in for these species in citizen science platforms, and I queried Rheocophila dorsalis in iNaturalist and observation.org, and as you can see, in total I got 6 points, so which is not very much convincing, and which also shows that it is difficult to involve citizens in monitoring such small and unseen species. Okay, next conclusion I have to draw here, there is limited data available, and this limited data might again be limited in reliability, as I have shown with the Rheocophila example. Okay, before I want to actually come to my final take-home messages, I want to tell something positive here, because this Europabon project and the European Biodiversity Partnership, Biodiversity Plus, they have teamed up to increase the efforts to shape the biodiversity monitoring and the biodiversity future in Europe. And the idea is that they want to commonly promote and support transnational biodiversity monitoring, and Biodiversity Plus will also test the operability of the European monitoring design that is or that will be proposed by Europabon. Okay, now let me come to my take-home messages. For the existing policies, we need better data reporting. So that means that we, for example, from the Water Framework Directive, we would possibly also get species data, which would help us for biodiversity monitoring. And then we also need to overcome the implementation gap, meaning the unwillingness to implement existing policies. And in terms of new things, we need European-wide, group-specific, standardized, systematic, of course, long-term freshwater biodiversity monitoring. And this has, of course, to be based on appropriate methods. This can, of course, include innovative methods like eDNA, but we need a reliable taxonomic backbone for all this. And of course, we also need the policy on our side. I mean, there needs to be a policy commitment for better implementation, and of course, also for better funding. And this very much boils down to something that I had heard earlier this week at the Europabon and Biodiversity conference, which was said by Mr. Kovacevic from the DG Environment. He said, we need to know more, and we need to make better use of what exists. And with that, I want to thank you for your attention.
Astrid, also for this very engaging talk and drawing our attention to some of the gaps and pitfalls that we might encounter when we want to use freshwater biodiversity data. And this will be an interesting discussion, maybe how can we engage with citizens then to fill some of these gaps later on. So our third speaker now is Ángel Borja. He is Dr. Ángel Borja. He's a marine ecologist working as a principal investigator at AZTI in Spain. His main work is making marine ecology research really useful for policymakers and management. He's interested in the effects of human activities in marine ecosystems, recovery after impact, protection, conservation, and also monitoring and assessment of marine status under the European directives, such as the Marine Strategy Framework Directive. His list of achievements and responsibilities is so long that I could easily talk through the whole slot duration. So he has really an outstanding publication record. And I think what is very important also in light of the discussion later on, he has also contributed to shaping the research landscape, for example, by being a member of the scientific committee of the European Environment Agency for a while. And he has worked on for several international organizations and EU projects related to the ocean. So Ángel, I'm very happy that you agreed to talk today, and we look forward to your presentation on the need of healthy ocean and marine biodiversity for human health and well-being. And I'm very happy that we can look at both of these sides in our session here, freshwater and marine. So the floor is yours.
Okay, thank you. Can you hear me? And can you see my presentation?
Both, yes. Yes.
Okay, thank you. Thank you for the kind introduction and for inviting me to give this talk on the need of healthy ocean for human health and well-being. You know that there is an increasing evidence of the complex links that there is between the ocean and the human health. You can see in this figure the different topics related with the blue growth in the sea and how this deal or links each other with the benefits for humans, for example, in these blue colors, or to harm to the humans in the orange colors, and also the links with the arrows with positive impacts in blue or negative impacts in orange. So it's important to note that this is related also with the provision of ecosystem services. And among the provision of these ecosystem services, the non-material benefits obtained from cultural ecosystem services are of paramount societal importance for human health and well-being. And an example of this ecosystem services cascade relating biodiversity with the human well-being could be the whale watching activity, which is an observational activity. I have made this figure from sizes classification, in which you can see that we have the environmental part of the ecosystem services, and then the social and ecosystem system, social and economic system. And this is like a cascade in which we have the supporting services, for example, the biophysical structures or processes, which could be the qualities of species or ecosystems that can be affected by the human activities and human pressures here. And these qualities of species or ecosystems are viewed or observed by people or enjoyed by people. And this is the function. The function is the capacity of this to be observed or to be enjoyed by people. And in this particular case, in the case of the whale watching or birds watching or seals, reptiles, etc., can be enjoyed by watchers, and this is the service, this is the final service from the environment. But of course, this whale watching can have benefits, and this enters into the social and economic system, and these benefits could be or could come from recreation, the fitness or the stressing or mental health or ecotourism. And finally, there is a value, an economic value, that could be the willingness to pay for whale watching, or even the savings in mental health for those enjoying the wildlife. And there are many examples of the links between the ocean and the human health, and I'm going to show you very quickly some few of them. This is a study made in England, linking the human health and the distance to the coast. The distance of the people living from the coast is taking all the 48 million people from England, and the controlling for area is income, education, unemployment, and crime. And you can see here that people living very close to the sea or to the coast reported better health than those living far away, especially far away from 6 kilometers from the coast. And the most interesting is that the effects are stronger in poorer communities, and also that people get happier and healthier when they move to the coast and vice versa. So that's important because it can be reverted, this gradient. And why is this? The people studying these things, that this is related with less stress close to the coast, more exercise, more social interaction, and more contact with the environment than the inland, living in inland or far away from the coast. Another example is again in England, they made a study of the people visiting protected and non-protected areas, and the outcomes were the mental health and connectedness to nature. And you can see here that, for example, in rural green, there is not too much differences. Even in the protected areas, there is better results, better situation, health situation. But for urban green and for coastal areas, people visiting protected areas reported better than in non-protected areas. So that's also an interesting result for that. Another example is very close from us, is that related with the COVID pandemic lockdown, in which we studied the contact with blue-green spaces during the lockdowns. We interview, or we recorded more than 5,000 people from 9 countries. And we studied the access to outdoor spaces and also direct contact with the nature. And then the outcomes were the mental health, depression, and anxiety. And we have 3 different levels of lockdown: very strict, mild or moderate lockdown, and not lockdown at all. And we can see that the level 1, the more strict show greater signs of overall poor mental health, and in the other two cases there is no clear differences in the poor mental health, but there are clear differences with the more strict. And we studied for this the more strict lockdown, if they have access to views for home, few or urban areas, or views, mixed views and natural views, and also access to outdoor spaces, non-access or balcony, garden or patio, or shared or public areas. And we saw again a gradient, the people having views from home of natural views, either green or blue, coastal, rivers, etc., presented better mental health than those who have fewer urban views. And the same for the access to outdoor spaces. People not having access to outdoor spaces presented poor mental health than the others in a gradient, in this gradient. Other example is the linking of the marine status and the capacity to supply ecosystem services. This is an example from China in 2 different bays in which they studied different ecosystem components here in the outside of these circles, and studied the status of these components, ecosystem components, and then they linked to different topics within the ecosystem services, and finally they related with supporting, regulating, or provisioning or cultural ecosystem services. And you can see that if the situation is bad in general, the provision of ecosystem services is lower. So it is, and in the opposite is if the ecosystem components are in a good status, the provisioning is higher. And they propose an index to measure the link between this ecosystem component status and the ecosystem services status. Another example is the change in marine state that affect the provision of ecosystem services and human well-being. This is an interviews to stakeholders in Australia, and the outcomes are the threats to social, cultural, and economic benefits, communities that came from marine state, and they reported this kind of links. You can see here the threats to the sea, the stressors, and then the links or the risk levels. For example, in this particular column is for the health and human well-being, and you can see that in most of the cases the risk is moderate. In other cases could be high, but in this particular case is moderate. So there is a clear link. Another or final example is that of the ocean and human health relationships in Europe. This was made by a systematic review of literature in the global focus, but also in Europe. And the outcomes is the evidence base for ocean and human health and relevance to European policy is growing, but remains patchy and poorly coordinated. And this can be seen here, in which they made a structured matrix of studies linking marine exposures and occupational marine exposures to different human health outcomes coming from cancer, cardiovascular, even mortality, etc. And they found this kind of links with different exposures. So that's also an interesting thing. So taking this into account, and taking into account that this research is patchy and is has low coordination, we proposed 2 years ago an agenda on ocean health and human health by taking into account the different evidences, trying to analyze in a critical way the marine data, the impacts on ecosystem services, the well-being benefits, etc. And we made this analysis taking into account several topics like climate change, the use of ecosystem services, pollution and ecosystem conservation, and we look for the research gaps in human health that need to be covered in coming years. For example, for climate change, we know that we are going to be submitted to more extreme events, and this can threaten the life in coastal areas. The sea level rise and migration of human populations can bring physical and mental impacts, and with this we need to be investigated. Or, I don't know, healthy and sustainable seafood provision, the omega-3 provision and affection to cardiovascular risk need to be studied, etc., etc. So there are plenty of different research gaps that we identify and that need to be covered in coming years. So as conclusions or home-taken messages, we have increasing global evidence of supporting links between ocean health and human health. Our health depends on many provisioning, regulating, and cultural ecosystem services and their good status. If we are able to transmit this idea of these links to the society and the policymakers, probably we can improve the sustainable use of the resources. One of the ways to undertake this is by monetizing the benefits that we obtain from the ecosystem services. Also, where you live is important, but less important than how you use the coast, for example, for recreation or other uses. Global research into public perceptions and preferences on ocean and human health are needed. And my last message is that we have a research agenda that needs to be filled in. And thank you for your attention, and I'm open to questions.
Thank you. Thank you very much, Ángel, for this very rich and inspiring talk. And no doubt that this is a very important connection that you outlined here in your talk, and it could be an interesting topic later on to see a bit how those both areas maybe can freshwater and marine can learn from each other and engage with each other and take some advantage of the experiences that either group has. But before we step in this discussion, I would like to particularly warmly welcome our last speaker, Twan Stoffers. He was selected for the last slot in our session, so he's a young scientist. He did his Bachelor of Science and Master of Science in Biology at Wageningen University in the Netherlands and specialized there in marine biology and animal adaptation. He has then started a PhD journey conducted in the aquaculture and fisheries group, also at Wageningen University. And I'm really impressed that you have the nerve a month before your defense to speak in a conference here. And what I found really impressive from your CV, that you not only managed to conduct up-to-date and top research for your thesis, but to continue on, I guess, what is a passion of yours to work on shark conservation, reef shark movement, and being continuously involved in protection of shark populations in the Caribbean. So I think your talk is really your experience is really a perfect match between the two areas we've heard about. But for the talk now, I'm looking very much forward to learn about some of the content of your PhD, so restoring floodplain nurseries to increase fish biodiversity. And the floor is yours. Thank you.
Thank you for the kind introduction. Yeah, so I do got experience on marine and freshwater systems, but today I'm going to talk about freshwater research, about my PhD research, the results of that, because I'm defending my PhD in a month time, so not nervous yet, but that will definitely come. So I'm going to talk about restoring floodplain nurseries to increase fish biodiversity. and that it's not a one-size-fits-all approach. So my PhD is about, well, it's aimed to better understand how restored floodplains function as a nursery for river fish, with the goal of improving recruitment success and restoring fish populations in the lower River Rhine. Well, this slide I put in, but it has been shown by by Dave and by Astrid already. So you see the freshwater decline is most severe of all the ecosystems on the planet. So I'm not going to go into detail on this slide. So why is that? Well, mostly because we humans modified our rivers. So they are the most modified freshwater ecosystems in the world. They're severely adapted for our benefits. So flood safety, energy production, navigation, and agricultural land use. This is a photo of the River Waal, so a branch of the River Rhine in the Netherlands, close to the city of Nijmegen. You see perfectly how we modified one of our river systems, to the extent that we lost the lateral and longitudinal connectivity in these systems, and also we have encountered a severe decline in habitat heterogeneity, habitat mosaic, and also in nursery habitats. So with the lateral connectivity, I mean the connectivity of the river with the hinterland, the backwaters, so the floodplains. And with the longitudinal connectivity, I mean from sea to source, the blockades that we put in our rivers along that axis. So why is habitat heterogeneity and connectivity so important? Well, first let me introduce the main players of my study. So we have different fishes living in our river systems. You can group them into different ecological categories. Here you see on the top left, you see the specialized rheophilics A, which prefer flowing water throughout their whole life, and need special flowing water habitats, of course, to fulfill their life history. Here on the right, you see the rheophilics B category, which are also specialists and prefer flowing water in certain life stages. Then we have the eurotopics. Well, they are present wherever there is water, so they just like fresh water. They can thrive within a wide range of habitats. And then we have the specialist group, the limnophilics, which prefer standing water and water plants throughout their life history. So why is habitat connectivity and heterogeneity important? Well, if you look at the life history of river fish, of fish in general, but especially river fish, you see that you have a larval stage, you have a juvenile stage, you have a juvenile adult stage, and you have the adult stage for spawning, for instance. So in every life stage, they have different needs for their habitat. They have different requirements. And to fulfill this whole circle, to fulfill this life history, they need connectivity between these habitats. For instance, for nursery habitats, the habitat that I looked into in my PhD, they really need refuge habitats for predator avoidance, for instance, for harsh environmental conditions, to shelter, but they also need feeding habitats, and often they are not the same habitat, so they need to migrate on a daily basis between these habitat types. The same goes for when you encounter juvenile fish. They need refuge habitat and feeding habitats, but those habitats might be different from the ones of the larvae. So they need different habitats at different stages of their life, and that's why the connectivity and the heterogeneity, the mosaic of habitats, is really important to increase the survival of those fishes, and thereby the biodiversity of freshwater biodiversity of our rivers. So in the Netherlands, we have done a lot on river restoration in the last, let's say, 30 to 40 years. So lots of river restoration happened. What we saw is the less than expected recovery of the fish communities and biodiversity in the main rivers. We didn't really know why, so it was important to really need a better understanding on the nursery habitat requirements of the young fishes, because we thought that was the bottleneck in this system. And for that, it's important to study the local habitat requirements, the role of connectivity herein, the spatial scale of habitat use, which scale do they actually use within their nursery areas, and the organization of the essential habitats that they need to survive. And this changes for life with life stage and species, which makes this a really complicated area to study. So what we did in within my research, well, we aimed on getting knowledge of the ecological functioning of those river restoration projects as fish nurseries to improve the biodiversity. So what we did, we had a large scale evaluation of 46 restoration projects, which you can see over here. So here you see the River Rhine in the Netherlands, and you see that within this area we have 46 different river restoration projects, which we evaluated the nursery habitat potential. We focused on 3 relevant spatial scales because we thought that's really important because they changed their scales throughout their life history. So we focused on the river level, so the river branch level. We focused on the restoration project level, so within a certain project. And then we focus on the sampling level. You see different sample areas over here. And we also wanted to see what the local habitat requirements were. We focused on 2 fish community responses. So we focused on biodiversity, so species richness, and on abundances, so species per 100 square meters or whatever. And we grouped the fishes into eutropic, rheophilic, and limnophilic ecological groups. So what we found was, first of all, if you look at the control, we used the river shoreline as a control. So you see a river shoreline like this, and we studied the isolated waters. We studied tidal channels. We studied one-sided connected channels, and we studied two-sided connected channels. So what we saw on the abundances of fish, for instance, if you compare it to the control, you see that two-sided connected channels have really high abundances of young fish, especially eutropic, but also rheophilic compared to the control. If you look at the gamma diversity, which is species richness in this case, you see that the highest species richness can be found for rheophilics in these two-sided connected channels. And also for eutropic fish, you see high species richness in those floodplain systems. Also, the one-sided connected channels perform really well on providing nursery area for those young fishes, for those river fishes. You see that the highest abundances overall were found in these systems, and also the species richness was really high compared to the other restoration project types. So if you want to award medals for different floodplain restoration techniques, then we could award the first place medal to the two-sided connected channels, in which we observed the highest species diversity, especially for those sensitive rheophilic fishes and high abundances. Then the second place go to the one-sided connected channels with the highest abundances overall, especially eutropic species and high species diversity. And then the split third place can be for tidal channels and isolated water, which have a function for other fishes, of course, which you don't really encounter in, for instance, the two-sided connected channels or the one-sided connected channels. So they all have a function, a different function for different parts of the fish community. So if you look at what makes those systems then suitable for fish, for young fish? So what are the higher habitat requirements within these systems for young fish? Yeah, we looked at 2 different levels then. We looked at the project level and we looked at the sampling level. So the level of one sample and the sampling and the level of the whole restoration projects. And what we observed was that, well, first of all, let me show you the project level are these areas and the sampling level is this area and the abundances is this, and the species richness and biodiversity is here. So I will walk you through it. So what we found was that flowing water has really a strong positive effect on species richness, as you can see here, both for the whole fish community and for the rheophilic species, even for the critical rheophilic species, you see that it's a really clear effect of increase of flowing water, of connectivity, which creates flowing water, has a strong positive effect on the species richness, but not on the abundances. The overabundances are a bit declining with increased connectivity, increased flowing water. What we then also saw was the habitat heterogeneity, or measured by shoreline diversity. We saw that it has a positive effect on overall species richness, as you can see here. So the more heterogeneous the habitat, the more species can live there, which makes sense, of course. But it has a negative effect on the abundances again. So there are certain habitats that are really suited to boost certain species, which leads to high abundances for certain species in one particular environment. But it doesn't mean that the biodiversity doesn't benefit from that specifically. And it depends on the spatial scale that you look. So the habitat diversity can be on a project scale really beneficial for species richness and negative for abundances, for instance. But on a local scale, a diverse small habitat is beneficial for the rheophilic fishes because they need really specialized flowing water habitat with the gradient of flow and the gradient of substratum sizes. So that has a positive effect on their abundances. Then shallow water habitats is really positive for rheophilic species, both for the biodiversity and for their abundances, and not so much for the overall fish community. Although shallow water is for young fish always a good sign because that warms up quickly and produces a lot of food. And then the project age, so the age after the age of the project after installment, you see that a negative effect on both species richness and on abundances happens when the project ages. So so if you look more into detail on that particular subject, so the long-term changes in the ecological efficacy as a nursery of restored floodplains, we found that there is an optimum for rheophilic fishes. There's an optimum age after restoration in which the highest abundances are recorded. That's let's say between 10 and 15 years of age, the highest abundances are recorded of rheophilic fishes. But the biodiversity of rheophilic fishes gradually declines right after the restoration took place. For your topics, you don't see that pattern. You see a bit of an inverse pattern, parabolic pattern for biodiversity. And why do we observe these patterns? Well, for the rheophilic fishes, well, they need specific habitat requirements within their first year, or within their growing up. And those sedimentation processes that happen in those modified rivers, as we have in the Netherlands and also many places elsewhere in Europe, you see that sedimentation process is really limiting the water flow after a couple of years, which means that flowing water conditions decline, and therefore you also see a decline in rheophilic fish species, which really need those flowing water systems. So for restoration, for restored floodplains in those heavily modified rivers like the River Rhine to remain effective as a nursery for those rheophilic fishes, regular maintenance is really essential. But I have to mention that it has to be geared to the local river conditions, to the target species, and to the fish community aspects. You cannot have one size fits all approach in this one. So I will also let me show you a bit of preliminary results on those what the habitat requirements that they need and the shifts in habitat that those fishes need within their first year. Because I showed you already that in the life history figure, that they need different habitats for feeding, for refuge, and that it changes over the season. So we identified different habitats, 5 different habitats within the floodplain system that we analyzed. And what we saw is that their habitat preference on the y-axis and their age or their size on the x-axis, you see that there is a shift in habitat use For Eurotopic species, you see that they shift from shallow water habitats to deeper habitats within the nursery, within the floodplain. For rheophilic fish, you see that they use shallow water habitats, slow-flowing water habitats for a long time until they reach a certain size in which they want to go to the river, which is the red line. And for limnophilics, you also see differences in habitat use throughout their first growing season. So in this respect, habitat heterogeneity is really important to sustain a high biodiversity of fishes within your restoration project. There are a lot of changes or differences within species, even within the ecological guilds that are used. And especially if you look at the rheophilic fishes, you see that they all use different habitats throughout their nursery area. You cannot say that rheophilic fishes all use singular or the same habitats throughout their first growing season, because that is not the case. So again, habitat heterogeneity is really important to sustain the high levels of biodiversity within your restored floodplains. So to conclude, there's no one-size-fits-all approach to restoring fish biodiversity, especially not in my study area in the Netherlands. So floodplain restoration works as a fish nursery, but the efforts are limited to the boundaries of the modified dynamic forces of regulated rivers. So it has to be case specific. Within a river, multiple types of complementary restoration projects are essential to restore those freshwater fish biodiversity. As I showed, the different project types have different beneficiary effects on the fish community. And within a restoration project, the presence of the habitat heterogeneity is really important for increasing biodiversity, but not so much for the rheophilic species, because they have really limited, they have specific needs, and those needs need to be fulfilled. The presence of flowing water in is essential. And an all-important element for success of fish nurseries and restoration projects is that they maintain a permanent lateral connection to the river. That is essential. Also with low discharge levels, they need to be connected because the fish need to move between those habitats that are really essential for them to survive and to grow. Thank you all for listening, and I'm looking forward to the questions that you have in the end.
Thank you very much, Twan, for this very interesting discussion as well. And it would be great now if also Mariana is also coming back to the stage. That is nice. And if also the other speakers could come back, please. So switch on your camera and then you should reappear and become visible again. The talks were hoping that Ángel will, yeah, he's joining as well. So thanks a lot to the four of you for these super interesting talks. We took a bit longer than we hoped, also due to a little delay at the beginning, but I think that doesn't matter so much. We will cut a bit the discussion we have now. I think something that came up also in the a reoccurring theme, I think, in your presentations was really this issue of complexity, right? Complexity as a system, as Dave put it, complexity in the data that we would need, that is available, or as it is available, complexity in the number of relationships that you presented, Ángel, or for now, your idea of these complex habitat use. So maybe one problem could be that the whole system is just too complex, right? So we had this idea of we need to move politicians and the wider public really to acknowledge the crisis. But how can we actually achieve this if maybe the system is a bit too it's hard to comprehend by more lay persons? So are there any ideas around maybe how we could improve on this side? Maybe we start with Dave also there, so we can do a bit of a round here through the table.
Well, let me first of all say how much I enjoyed all the other presentations. It's been a great learning session for me. Thank you, everyone. And yeah, good question. Complexity. How do we deal with complexity in a world where, you know, we need to make rapid change if we're going to bend that curve, if we're going to restore biodiversity, not just in freshwater systems, in marine systems as well. It's a constant dilemma for anybody who sits between science and policy, as I do. You need to simplify messages. You need to come up with sort of generalized approaches in order to inform policy debates. But you also need policy frameworks to allow sufficient flexibility that they can cope with the complex dynamics of these aquatic systems. There's no sort of silver bullet to that. There's no sort of magic solution. I think one of the essential success factors, though, is allowing adaptive management, and the more science can produce tools which inform adaptive management, and policy encourages management of aquatic systems which is adaptive, including to, you know, unforeseen circumstances which may be coming down the road, and that's a very live issue with climate change looming. Then the better equipped we'll be to cope with complexity, including, you know, known unknowns, if you like. So yeah, I think just being realistic about the extent to which we can balance simplicity of messaging and simplicity of policy frameworks with complexity of these ecological systems, and facilitating adaptive management. I think those are the two things that come to my mind.
Yeah, thank you very much. Astrid, do you have any ideas like how this could be aided by the data case you're trying to make?
Well, there is no easy answer to complexity, I would say, and I totally agree with what Dave had said. I also want to agree with someone who had mentioned this in the chat. This complexity issue and also this data issue are not to be meant to be an excuse for not moving things forward. And so river systems or freshwater systems are complex, but we need to really work on how we better sell this to politicians and to the public. So I think we should not work on, or should not focus our work exclusively on to disentangle this complexity, but rather to how to communicate this complexity in a more easy and understandable way.
Yeah,
There's a big agreement.
Yeah, I fully agree with Astrid. In the last 20 or 30 years, we have made more complex studies on these systems. In my case, in the case of the marine systems, trying to incorporate all the ecosystem components into the analysis, in the modeling, etc., and moving from single management or single species or single habitats to more complex ecosystem-based management approaches for the management, and I think that this is the trend, the tendency now. But we, as commented by Astrid, we need to then try to simplify the findings from these complex systems to be transmitted to the policymakers, managers, and especially to the society, trying to send clear messages about the findings we have from the complex systems.
Yeah, thank you. Twan, do you want to add something?
Yeah,
from your own?
I completely agree on the things that have been said. I mean, well, the idea behind my PhD is to unravel the complexity of nursery habitats for fish, which I tried to do, and I showed some nice results on that. But I think there's quite some agreement among scientists about the causes of decline of aquatic biodiversity, and particularly with regards to fish. So in that case, more research is not a pressing issue, but it's about how to get that our results well to the different stakeholders, how to simplify it, and giving presentations, hosting symposia, writing articles in non-scientific journals. And for that, you need not every scientist is good in that. You have you need a particular kind of scientist for that. That is really likes well, what I think what Dave was mentioning, the activist scientist that really tries to get that word out to the general public. So it's critical that scientists need to be trained to deal with those various media channels, for instance, that we can use to try to get the public, to bring the message out there to the general public and to the politicians.
Mariana, do you want to add to this?
Yeah, I was thinking that perhaps it's not just that the scientists need to be trained different, but we need other people, connecting people that have the other way around. So people that are good in translating science should be able to understand science. So people that have some kind of scientific background are better, have better tools to transmit and talk to other stakeholders than the regular scientists. So it's I don't think all the burden should be on scientists, but we have to increase the network of people that are really caring about nature and to improve the situation of nature to reach better. And in the chat, there are people saying it's not just the politicians and the general public, but also those that are handling the funds. Because when there are trade-offs between nature and access to food, for example, then the nature loses. And the same with access to water, and then you name it. So every time there is a conflict, then nature loses. So it's kind of the easy way out is just to exploit more and more to secure human needs, the short-term human needs. So that there are many interesting messages in the chat and questions that we are suddenly lacking time. So it's hard to choose where to focus. What do you say, Sonia? I have copied all the questions. There are some questions that are addressed to some of you and others that are more reflective for this collective thinking that we're doing now.
Yeah, I think there is one that strikes me particularly is this aspect of cooperation. So I think this has been raised a number of times. So cooperation or communication cooperation, of course, with the wider public, but then also with particular groups and really working across different sectors, which I think is probably one of the really large challenges. So it might be very straightforward to think about some engineering issues we have, think about the bridges, dams, and so on. But then there might be other sectors that are very important, but much more hidden from our perception, at least, like the financial sector and so on. And I would be interested if they have any experiences also how to engage with these groups. That could be the last question. Maybe cannot be answered by everyone, but maybe if someone has some experience with that, that could be a great final round here.
I can chip in a little bit on that, Sonia. I mean, I think it's a great question. It's the $64,000 question. You know, how do you influence the people who need to be influenced in order to change the world? And those people consider multiple sectors, including finance, various industrial business sectors, as well as government and the wider public. I guess I've been grappling with this for the last 25 years. You know, this is partly my job and the job of my colleagues in WWF and across the NGO movement. It's not easy. It's an ongoing process. A lot of it involves learning how to frame the challenges in ways that resonate. I think so, using the right language, not being too scientific about things. It relates to that question about complexity versus simplicity. Knowing when to have those conversations, when the opportunity presents itself, and perhaps when not. How to relate challenges of aquatic biodiversity restoration to things that these people actually care about. To give a practical example, a lot of the private sector at the moment across sectors like food and mining and textiles, they're very concerned about water-related risks to their business. This is the language they talk about, business risk. And so trying to translate some of the issues around biodiversity restoration into approaches that can also help mitigate business risk. We've found in WWF has been tremendously fruitful in terms of opening conversations. It's not a panacea, it doesn't lead to magic solutions, but it helps you open those conversations and begin a dialogue. And you learn from each other as those dialogues go on. So yeah, there's, and I guess the other thing, I'm minded of Jay O'Keefe, who was a professor at Rhodes University, who passed away sadly about 3 years ago, a global expert in environmental flow assessment. Jay used to talk about hot moments. So moments when just opportunities presented themselves. The classic he used to talk about was the collapse of apartheid in South Africa, where suddenly there was this whole new approach to governance and to policy as the ANC came into power, and it provided a massive opportunity to rethink the way water was managed, and they managed to integrate environmental flow considerations into that. So really just learning to recognize when those hot moments are likely to appear and being in a position to grasp those hot moments, including through using some of the skills that I flagged in my presentation. For me, that's pretty critical.